Welcome to module 1.9. In this lecture video, I'm going to show you how to calculate the prime factorization of a composite number. So if you look back on the handouts at the beginning of 9.1, it mentioned something about, the second page, mentioned something about every composite number has exactly one prime factorization. So what that means is there's only every composite number, there's a set of prime numbers makes up that composite numbers. So the way I'm doing this a little bit different. Some textbook call this alternative ways. So basically, I'm going to put my composite number inside this upside down division, and on the outside, I'm gonna find a prime numbers that can go to 77 evenly. So if you think about it, 7 will work because 7 going to 77 11 times. Oh, 11 is also a prime number, so let's keep going. Only 11 can go into 11 one times. So when you see this 1 in the bottom, that's how you know you need to stop. So all these numbers on the right-hand side, on the left-hand side, are the prime numbers that makes up 77. So the prime numbers that makes up 77 is going to be 7 times 11. Okay, this is exactly one prime factorization. All right, 63. Let's give a try. Put my 63 inside this upside down division. On the outside, I will find me a prime number that can go into 63 evenly. So I mentioned something about popular prime numbers. So we always starting off with like 2, the 3, the 5, the 7, maybe sometimes 11. Okay, rarely we will go up to even like 17 or 19. So by divisibility by 3, okay, 6 plus 3 is 9. 3 can go to 9, 3 can go to 63. By divisibility by 3, it tells me I can use prime number 3 to do it first. 3 going to 6 2 times, 3 going to 3 1 time. So I'm not looking at the 63 anymore. I'm looking at the 21 I end up. So another prime number can go into 21. I can use 3 or 7. It doesn't matter because you're still going to end up with both of them. So if I say 7 in this case, 7 going to 21 3 times. 3 is a prime number. Only 3 can go into 3 one time, and that's when you stop. So the one set of prime factorization that makes up my 63 is 3 times 3 times 7. Okay? Very important you understand how to do this. Now, some students can do it just by looking at this and say, well, that's 63, right? 63 is 6 times 7. So I can break down 6 again using 2 and 3. Oh, no, not 3. 9 times 7. I'm sorry, I don't know what I'm saying. 9 times 7. So 9 is 3 times 3. You can do it that way, or you can do it the vertical way. Okay, whatever is quicker for you. Now for big numbers, I definitely like to work it out using an alternative way. So I'm gonna put my 315 inside this upside down division. So by the prime factorization of 5, I know 5 can go into 315, and 5 is also one of my prime numbers. Okay, so let's give it a shot. 5 go into 31 6 times. The remaining 1, bring down the 5 go into 15 3 times, so that's 63. So this is the same 63 as up here. That 63 itself is made out of 3 times 3 times 7, because I can use 3 again going to 63 21 times. I can use 7 again going to 21 3 times. Since 3 is a prime number, only 3 can go into 3 one time. That's when I stop. So all these numbers on the outside multiplied together will be 315. So the prime factorization, the prime numbers that we use to break down 315 with is 3 times 3 times 5 times 7. Okay? All right, that's what prime factorization means. All right, let's try a different kind of problem. Okay? Do both of them. find the prime factorization and finding all the factors. We'll do 2 of these. So let's break down my 50. So some students are quicker than others, which is fine. Some students say, well, Mr. Chen, 50 is already 5 times 10. 5 is a prime, 10 is not. Then 10 can continue to break down as 5 times 2, which is true. Or you can do the alternative way or the vertical way. 5 going to 50 10 times, keep going. 5 going to 10 2 times. 2 is a prime number, 2 going to 1 time. And that's when you stop. So either way, all these numbers on the outside, 5, 5, and 2, 5, 5, 5, and 2 are my prime numbers that we can use to break down 50 with. Okay, that would be my answer. 2 times 5 times 5. I always put small one on the front, just a habit. All right, find all the factor of 50, okay? All the factor of 50 means start out with 1 times 50, and then try 2, then 3, then 4, so on and so forth, until you're repeating yourself. That's how you know you're going to stop yourself. 2 go into 50, most of y'all know this, 25 times. 3 cannot go into 50. 4 cannot go into 50. 5 can, 10 times. 6 cannot. 6 times 9 is already 54. 6 times 8 is not quite enough. 7 cannot, 8 cannot, 9 cannot, and 10 can. So that's it. So all the factor makes out 50. 1, 2, 5, 10, 25, and 50. Go this way. All right, for 150. Ooh, this number is a little bit bigger. Let me break it down. All right, prime number, I can use a 5 or 2. Doesn't matter. I'm going to use a 5. 5 is a prime number, can get this thing down quick. 5 going to 150, 30 times. Oh, I can use another 5 or 2 or 3. But it doesn't matter. I'm still going to end up with all those numbers I just named. 5 go to 30 6 times. Now look at the 6. Prime number 2 or 3 can go into it either way. 2 go into 6 3 times. 3 is a prime number. 3 go to 3 1 time. So the prime number that makes up 150 is all out here, which is exactly 1 prime factorization. 2 times 3 times 5 times 5. Excuse me. All right, now finding all the factors. Now this time, this might take a little bit of work because I got quite a few sets. And up here can also help, okay? Up here can also actually help you to determine right here. 1 times 150, obviously. 2, see that 2 right up here? 2 will go into 150 how many times? 2 will go into 150 25 times 3, which is 75 times. Can 3 go into 150? Sure it can. See the prime number 3 right there? 3 go into 150 how many times? 3 go into 150 how many times? 5 times 5 times 2 times, which is 50 times. See? That's how we do it. We don't have to actually do long division. We can just look at these numbers, use multiplication. Can 4 go into it? No, because you don't see any 4 right here or 2 2s. If I got 2 2s here, 2 times 2 is 4. That can work. All right, 5. I see a 5 right here. 5 will go into 150 how many times? 30 times. See the 30 right here? 5 times 2 times 3 is 30. All right, 6. Do you say 6? Sure, I do, because 2 times 3 is 6, right? 6 will go into 150 how many times? 25 times. So if you remember divisibility by 6, if 2 can go into it, 3 can go into it, then 6 can go into it. How many times? See, the 6 is right here. Go into it 25 times, because 5 times 5. 7, 8, 9, 10. 10 is right here. 5 times 2 is 10. 10 will go into 150 15 times. 5 times 3 is 15. And I think that's it, right? 11, 12. You can't make a 12 out of here. 13, no 13. 14, no 14. 14 is 7 times 2. 15 I already got, so that's the end of it. So all these 1, 2, 3, 5, 6, 10, 15, 25, 30, 50, 75, 150 are all the factors or divisors that can go into 150. All right, so in this lecture video, I'll quickly show you how to break down any composite number using prime factorization, and we also kind of review a little bit on how to find all the factors of a given number. That will conclude this lecture video. Thank you for watching.